Hello friends, in this video I'd like to solve the following problem from the Spanish Mathematical Olympiad, final round 1971, problem number 1. We wish to evaluate the following sum, as b goes from 5 to 39, of this number 1 sub b over 2 to the power cube root of 1331 sub b, knowing that the number 11 and 1331 are written in base b. So these numbers, they are written in not necessarily in decimal system, but in base b system. So my hint for this problem, first of all, here is the hint about number systems. If, for example, if I have a number which has digits x, y, and z written in base b, recall that we take each digit and multiply it by consecutive powers of b. So this number, x, y, z in the base b, is z plus y times b plus x times b squared, etc. Moreover, that can simplify our sum a little bit. Moreover, once you eliminate this this convoluted notation, recall that we have the following formula for the sum of geometric progression, and differentiating this equality might be beneficial at some point. So give this problem a try, and I will see you in a minute. Okay, so my solution, first of all, what's 1 in base b? It's just 1 plus b. And what is 1331 in base b? Well, it's 1 plus 3 times b plus 3 times b squared plus b cubed, and that is 1 plus b to the third power. So denoting our sum, let's say by letter S, we now know that we wish to evaluate the sum which goes from b equals 5 to 49 of 1 plus b over 2 to the power, let's look, we have cube root of 1 plus b cubed, so it's 1 plus b. And now let's move our index of summation a little bit. So instead of b plus 1, I will put k. So k would go from 6 to 50 of k over 2 to the power of k. And I will do one more thing, because this sum goes from 6 to 50. Usually it's easier to consider sums going from 0. So I will write this as sum which goes from 0 to 50, or from 1, because the 0th term is 0 for this sum. So k over 2 to the power of k minus, well, the sum which goes from 1 to 5. Okay. Now, the first sum is problematic. I will write it, you shall see in a moment why I do this, in the following way. Sum with over k which goes from 1 up to 50 of k to the power 2 to the power k minus 1. And not 2, sorry, 1/2. 1/2 in fact. And the second sum, it can be written out explicitly. It's just 1 over 2 minus 2 over 4 minus 3 over 8 minus 4 over 16 minus 5 over 32. And finally, this second sum can be easily calculated by hand. It so happens to be, let me look at my notes, it happens to be minus 57 over 32. Okay. Now, the real challenge is to evaluate this sum. There are many ways. If you know indefinite summation, which is nicely covered in concrete mathematics textbook, for example, it can be used. You can also use induction or something like that, but my favorite method for computing these types of sums is the following. recall the following, that 1 plus x squared and so on plus x to the power of 50, it's 1 minus x to the power 51 over 1 minus x. Okay, it's just the formula for the sum of geometric progression. And now, how is it helpful? It will be helpful after differentiation. So let's take this equation and let's differentiate both sides. What will we get? We will get the following. 1. The derivative of 1 is 0. The derivative of x is 1. Plus 2x. The next term will be 3 times x squared, and so on. The last term is 50 times x to the power 49. And on the right hand side, well, we have to differentiate the quotient. We will have 1 minus x squared in the denominator, and now the derivative of numerator is minus 51 x to the power of 50 times 1 minus x, minus the derivative of the denominator is minus 1 times 1 minus x to the power 51. Okay, and now let's write the left hand side in our sigma notation. So it's sum which goes from k equals 1 up to 50 of k times x to the power k minus 1. And after simplification of the right hand side, you will get 50 times x to the power 51 minus 51 x to the power of 50 plus 1 over 1 minus x squared. Would you look at that? That sum looks a little bit like our sum which we wish to evaluate, because we have k and we have power k minus 1. Let's now set x to be 1/2. X to be 1/2. Then we will get the following. Sum which goes from 1 to 50 of k over 2 to the power k minus 1 is 50 times 1/2 to the power 51 minus 51 times 1/2 to the power of 50 plus 1 over 1 minus 1/2 is 1/2, so we have 1/2 to the power of 2. And also, since we have 1/2 in front of our sum, let's put also 1/2. Why not? Okay, now that's something. And we have the following. Our sum. And now it's just the matter of simplification of the right hand side. After simplification, I will leave the details to you. It will be 2 minus 13 times 1/2 to the power 48. After simplification, I leave the details up to you. And now, that means that we have the following. Our sum is just this number minus what? Minus 57 over 32. And that is, after simplification, 64 minus 57 is 7. 7 over 32 minus 13 over 2 to the power of 48. And that is our answer. Our sum is equal to this quantity right here. Okay, so thank you for watching. I hope that you've learned something new this time. Remember this trick of differentiation, of considering geometric progression and differentiating it. Because in that way we can produce k. After second differentiation, we will get k times k minus 1 and so on. this is very handy way to deal with these types of sums. Thank you for watching, and I will see you soon.